All right, so we're going to continue talking about characteristics of functions. And the first thing I want to do is to just quickly review what we did in our flip chart here. So we created our flip chart just to help you out with the different characteristics that we're going to be looking at. So domain and range. So domain, we're talking about the x values of our function, and the range is talking about the y values. When we look for the intercepts, we're looking at the point where the function crosses either the x-axis or the y-axis, depending on which one you're looking for. For maximum and minimum, that is literally the highest or lowest point on a graph. Increasing and decreasing, what we're doing here is we're looking at what's happening to the y values. So here the y value is getting larger, here the y value is getting smaller, and here the y value is getting larger. And what we're going to do is talk about when on the x-axis those things are happening. So that's going to be in interval notation, which we're going to review in just a second. Positive is when the function appears above the x-axis, and negative is when the function appears below the x-axis. And then end behavior, we're not going to do that much with end behavior right now. We're going to do a little bit more with that in the next unit. But what we're talking about is when the graph has arrows on the ends, it's going to continue going in a certain direction. And what we do is we look at the ordered pair for that quadrant, and we look at the sign. So like if the arrow continued in this quadrant, it's just going to get more and more positive on the x and more positive on the y. But if our arrow was in this quadrant, the x is going to get more and more negative, and the y is going to get more and more positive. And that's because the values in this quadrant are negative x and positives for the y. So, but again, we're going to look more at that in our next unit. So what I'm going to do in my spiral is I'm going to go to the next page, and I'm calling this characteristics of functions continued. So characteristics of functions continued. And if at any point I am going too fast, remember that you can always pause or replay the video if you need to catch up. So what I want to do on this just real quickly is mention the interval notation. So we talked about it quickly yesterday, but interval notation is how we are writing some of our answers for like domain and range and increasing and decreasing, those kinds of things. So when your function has actual endpoints, that is when we are going to use brackets. So it's almost like this is a stop sign. So we are starting at this point and we are stopping at that point. If you remember, we put the lowest value, comma, the highest value. And then those are going to go in brackets if we have endpoints. So what would happen otherwise would be if there were arrows at the end of our function, then what's going to be happening there is the arrow implies that our function just continues on forever. So we don't have endpoints. It's just going to go on forever. So if that's going in a positive direction, that would be a positive infinity. If it was going on forever in a negative direction, then that would be negative infinity. And infinity is like a sideways 8. You could even just make like two circles, two ovals next to each other, could look like an infinity. But anytime we have infinity when we're talking about our function, we use parentheses. So I kind of think of this as more like a yield sign, because we're never going to get to the highest number. If something goes on forever and ever and ever in a positive direction, we're never actually going to stop at it, where if we had an endpoint, we would be stopping. So I say that this is more like a stop sign. And then this is more like a yield. And I know that you are not driving yet, but I think you probably know that a yield is more of like a slow down, caution, but we're not actually going to stop. All right, so the next part of our video, I want to go to this worksheet right here. And so I am going to glue this into my spiral, but I'm going to talk you guys through this one just to get you an idea of the characteristics and how we complete the answers. So let me turn on the light there. That'll help out a little bit. All right, so first thing is domain. So again, we just said a minute ago, just to review, that domain is talking about our x values. So this is our domain right down here. So in this graph, we are looking at the number of cars sold during the first half of the year. So we have information going from January through June. So for our domain, we can write it two ways. One thing we could do would be to say that we have information from January, until June. The other thing is, since it is math class, it would be okay to say that January is month 1 and June is month 6. So we have information on our x. So our x values are running from 1 to 6, which would be the month number that corresponds to the month. All right, so then for our range is talking about the y values. Now what you have to be careful of is it's not necessarily what's on the graph, but it's what's in our data. So the range of the number of cars goes from 20 to 45. So our range is going to be from 20 to 45. Now, the graph goes from 0 to 50, but our data goes from 20, which is the lowest y, up to 45, which is the highest y. So this right here is our range. All right, increasing and decreasing. So what I'm going to do is to go through my graph right here and label what's happening. So this piece right here is increasing, and then I get to about February, it looks like, and then I didn't sell as many cars then, but here I increased again from March to April, and then also from April to May. So I'm going to say that that whole piece right there is an increase. And then right here at the end, our sales went down again. So first thing I'm going to do is label the graph. Then what I'm doing over here is I'm going to say when this is increasing and when it is decreasing. So this is going to be when. All right, so car sales increased from January to February. So I'm going to use the numbers. So starting in January, our sales increased from January to February, but it didn't end at February. It just turned. And then my car sales decreased between February and March, but it didn't stop in March. It just changed. And then my car sales started increasing between March to April to May. So from March to May, my sales increased, but again, they didn't stop. It just kept going. But from May through June, my sales dropped. So I had a decrease in my sales, and then that's where the data ends. So basically what's happening here is I'm shifting between increasing and decreasing, increasing and decreasing. So from here to here, the car sales were increasing. From here to here, my sales decreased. Between March and May, my sales increased. And then again, between May and June, my sales decreased. All right, next, maximum point. So the highest point on my function is right here. And that is a point, which is written as an ordered pair, and ordered pairs are always in parentheses. So this occurred in May, and my sales were 45 cars. So, or we could write it as 545. So what that tells me is that I sold the most cars during the month of May, and that's when I sold 45 cars. And then the minimum point, and again, this is a point, I am looking right here. So here's my lowest number of cars sold, and that occurred in January. So I could say 120, or I could say January and 20. So what this tells me is that I sold the fewest number of cars in January, and that month I only sold 20 cars. All right, again, those were points. So ordered pairs always have parentheses. All right, let's move on to the next graph. So this graph shows the value of Sarah's car. So we're going to use this graph to go through these same characteristics again. So first up is the domain. So we have information on Sarah's car going from 2000 until 2007. So the domain is 2001 to 2007. I might have just said 2000, so I apologize if I messed that up. All right, now we're going to look at the range. So the range, now the graph goes from 0 to 25,000, but the range of her value goes from $5,800 to a value of $24,000. So the range of the cost of the car, the value of her car, even though the graph went from 0 to 25,000, the value of her car went from $5,800 to $24,000. All right, so now we're going to look at the graph to locate the times when the value increased or decreased. And it looks to me like it's decreasing, and it looks like this, oops, get the marker to work here. It looks like the value of her car is decreasing the entire time. So for increasing, there was no point in between 2001 and 2007 that her car value increased, but her car value decreased the entire time. So from 2001 through 2007, the value of her car decreased, and those are stopping points. So it started and it stopped at those points. All right, maximum point is going to be right over here. So in 2001, the value of her car was $24,000, and that was the maximum value. And then down over here is the minimum point. So that ordered pair is 2007 and 5,800. So in 2007, the value of her car was $5,800.